The next topic that comes about in section 8.4 are parallel and perpendicular lines. Parallel lines have the same slope, okay? You might see something that would say M1 equals M2 or something like that, that the slopes are equal to each other, okay? Now, perpendicular lines, that's lines that meet at a right angle, a 90-degree angle. They have slopes that are negative reciprocals of each other. So example of negative reciprocals would be if M1 was equal to 2 over 3 and M2 was equal to negative 3 over 2. Okay, so they'll have opposite signs, and then there'll be the fraction will be flipped over. That's a reciprocal. Okay, so if we're given this line and they say, okay, what's a line that a slope that would be parallel to this line, and then a slope that would be perpendicular to this line. When we look at this, it's not in slope-intercept form, so we can't immediately see the slope. Some of you maybe have already done a little math in your head, and you have figured out that the slope is going to be, I believe, negative 3/7 for this line, but I'm going to do the math to check that. So to see the slope, I'm going to take this term, I'm going to move it over here. Remember, that's adding 3x, so I have negative 7y equals 3x plus 4. I'm going to divide by negative 7. Okay, at this point, I can see the slope of this line. Okay, it's sitting right here. It's in front of the x value. There's the slope. All right, so the slope is, and remember we like the negative sign on top here, so the slope of this line is negative 3/7. So what's a line that's going to be parallel to it? It's going to be exactly the same, right? Because that's our definition and what we know about parallel lines. And then for the perpendicular, it's going to be this fraction flipped over and then change the sign. Well, if this is a negative fraction, so the perpendicular is going to be a positive fraction. All right. That's a little bit about parallel and perpendicular lines and their slopes.